this video, we're going to take a look at how to shift elements of an array. And I think let's imagine a movie theater. So here we have a bunch of chairs. Yes, that's a chair. That is a chair. And I meant for these chairs to look like they're arranged left to right, so we'll just go with this. And I have some people in those chairs. So let's see. There's a person, there's a person, and there's a person. Let's give them some names. Let's say this is, let's go with some nice two-letter names. This is Bo, and this is Sai, and this is Dai. Let's see, Dai needs some pink hair, I think. That's pink hair. Okay, Bo, Sai, Dai, and Ed. And they're sitting in these chairs. They're maybe at a movie theater. There's a row of 4 chairs, and someone arrives. And that someone is, let's say, Al. So Al arrives. Let's see, Al is still standing because there's no seat for him yet. So there's Al, and of course Al is wearing a baseball cap, like that. Okay, there's Al, and Al wants to have a seat at the beginning of this row. And for Al to take a seat, Al is determined to sit over here next to Bo. But of course there is no chair next to Bo. So what's going to happen is Bo, Sai, and Dai are all going to have to slide down. Let's draw that. All of these people, these 3 people here, are going to slide 1 seat down to the right, which means poor Ed over here is going to fall out of his chair. So that's the plan. Al is going to sit down at the beginning. Everyone else is going to stay in order, because Bo is already pretty happy sitting next to Sai, and Sai is really psyched to be sitting next to Bo, and especially Dai, who he kind of has a crush on because of that cool pink hair. So we want to keep these 3 people in their original order. We're going to insert Al at the beginning, and we're going to slide them over, and Ed's going to fall out the end. And we're going to see how to write the program that will do that for us. So these 4 chairs here represent an array. So that array is traditionally numbered from 0. So it's 0, 1, 2, 3. Those are the indexes of my chairs. And we're going to write the program to do that. And the first thing to observe is who has to move first? Who has to move first? Actually, there's more than one way we could do this, right? Bo here could get up so that Al could sit down. And when Bo gets up, Bo needs to sit over here, so Sai would have to get up so that Bo could sit down, and then Dai would have to get up so that Sai could sit down, and then Ed would get up so that Dai could sit down, and at that point Ed would be standing and have nowhere to sit, which is our depressing goal here. So that's one way to write it, but I think that way is actually harder to write. I think there's an easier way to think about it, and that's to have, what if the first person who moves is Ed? If Ed moves first, then there's a vacant chair that Dai can slide into, and now there's a vacant chair here that Sai can slide into, and now there's a vacant chair where Sai was that Bo can slide into, and now the first chair is vacant and Al can sit down. So I think that's going to be the easiest way to have these to write the program so that these people sit down. But we don't have to write it that way. We could start at the beginning, but I think starting at the end is going to make things easier. So here's what we're going to ask ourselves. Actually, let's make a little chart here. So here's the seat that the first person moves from, and here's the seat that that person moves to. So who's going to move first? Well, we said the easiest way is for Ed to move first so that these people can start sliding down. So let's make Ed move first. So that means the first move, well actually Ed isn't really a move so much as we need to get rid of Ed. So first step, get rid of Ed. First step, eliminate Ed. Second step, though, is to shift Bo, Sai, Dai to the right. And that means who's going to move first of Bo, Sai, and Dai? The easiest way is to make Dai move first. So Dai is moving from seat 2. Dai gets up, and then she sits down in seat 3 where Ed has been eliminated, so Ed's not there anymore. So the first move goes from seat 2 to 3. The next move, now that Dai has moved, in fact, maybe we should draw that. So here we go. Ed has been eliminated, and so is part of Ed's chair. And then Dai has now moved from 2 to 3. So here's Dai now in 2 to 3, and of course Dai still has her hair dyed pink. Okay, actually no, let's say that's her natural color. It's not dyed. which is probably why Sai over here is so determined to sit with her. So this is Dai here now. So let's write that too. So here's Dai. Ed has been rejected. So here's Ed. And Ed is sad because he lost his seat. Something like that. And then Sai is going to move over here. So here's Sai can now move from seat 1 to seat 2. Let's make a note of that. Sai is moving from 1 to 2. Okay, so there's Sai going away. Here's Sai now sitting, and we'll just go with green here. Sai is in seat 2. And then the last move is going to be Bo moving from seat 0 to 1. Bo moves from 0 to 1. So here's Bo was in seat 0. Now Bo is in seat 1. Bo is apparently the same color as his chair now. I don't know, maybe he fell in some paint on the way from seat 0 to seat 1. And now we've got Al over here who can finally sit down. So Al can now sit in what is left of seat 0 over there. So that's our third step. Al sits in seat 0. So that's the plan. Here's the observation now. Notice that in writing this program, we're almost certainly going to have a loop. And we're going to loop from, it looks like, either from 2 down to 0, or we can loop from 3 down to 1. Either way will work. So one of these two ideas, either the seat we're shifting from or the seat we're shifting into, is going to become our loop index. And we might therefore be tempted to write the program and say, let's see, for int I equals, and so on. But if I start with if my loop index is I, well, now I have to remember in my mind, did I mean the seat I'm moving from, or is I the seat I'm moving to? Either one of those answers is fine, but I better know the answer. And because I better be clear about which one I mean, I'm going to make sure that I pick a nice variable name like from or to correspond to this chart. And I think we will attempt to solve it both ways. So let's start in on this program. So I'm going to imagine I'm programming in Java. I'll call this method shift. Let's see, we're shifting to the right. We'll call it shift right. And shift right is going to take an array of persons. We'll just call it people. And it's going to take a new person. New person, P, which in our case was Al. And it's going to return, let's return the old person, the person who's been shifted out. So in this program, if I were to run on this particular array, my array starts out being Bo, Sai, Dai, and Ed, and I pass Al, and at the end of this method, the array is going to contain Al, Bo, Sai, and Dai, and Ed will be the return value. And my method is static because, well, it doesn't really have to be static, but it doesn't depend on any state of any particular object, so I've declared it as static. And let's start in on writing that program. Let's see, I don't think we're going to be able to see all of this, so we'll maybe scroll down to there. Okay, first step, eliminate Ed. Now where was Ed? Ed was in the rightmost seat. That was the highest index. Before that was index 3, but here it's going to be whatever my last index is. So if people is my array, my last index, the length of the array is people.length. The indexes start at 0, so the last index is people.length minus 1. And I want to take the person in that position and eliminate them. Eliminate them, whatever that means. So we'll take a look at what code it takes to do that. So we'll eliminate that person. Then we're going to shift all these people over. So I'm going to use a for loop since I need to repeatedly move one person. And as I said before, my integer is either going to be the seat I'm moving from or the one I'm moving to. Let's use from. Let's use from, and then we'll try it again in the next video with to. The first seat I move from. So actually the key questions you want to ask yourself as you write this program is who moves first, from where to where? Who moves last, from where to where? And if you know that, you'll be in good shape for writing the program. So who moves first? Well, the rightmost person moves first, and they move from the second to last seat to the last seat. So where do they move from? Where do they move from? They move from the second to last seat. Right? This is psi moving from the second to last seat into the last seat. We move from the second to last seat. So the second to last index is people length minus 2. Then to answer the next question, we need to know who moves last and where do they move. So the last person to move is the person in seat 0. They move from seat 0 to 1. So last person is moving from seat 0. Well, if they're moving from seat 0, that means from has to go all the way down to 0. So I can do that as from is greater than or equal to 0. Well, from is greater than or equal to 0. And then what happens to from? From is decreasing. So even though everyone is shifting into a higher number seat, the wave of movement is shifting to the left. Die moves first, then psi, then bow. The wave of movement shifts, sweeps from right to left. So the first person we move is the second to last seat, and the last person we move was in the first seat. Okay, now for the movement itself, we're going to take a person from one position and store that person in a position, in a different position of the array. That will be the movement. So who moves? Well, the person who moves is the one at from. From. And the place they move to is they move one seat to the right, and as you can see, the place we're moving to is always one higher than from. So move to position from plus 1. And then having done that, we're supposed to actually sit person P all the way on the left, right? Al sits in seat 0. So person P is going to sit in seat 0. Finally, there's this business of eliminate this person. Well, if I don't have this code at all, that person will effectively be eliminated, because when die sits on Ed's seat, Ed will get squashed out of existence, since an array position can only hold one person. So when we copy die into the position that Ed occupied, Ed is gone. But our method was supposed to return the person. Let's make a note of it. It's supposed to returns the person who fell out the right end of the array. And who fell out the right end of the array? This person. So we want to return this person. That means we need to remember that person in a variable. This is our removed person. And then when I'm all done, I can return that person that I remembered, the person who fell out of the right-hand side. In the next video, we'll take a look at how to write this starting with using the variable to instead of from, and then we'll take a look at what happens when we shift in the other direction. I will see you there.